Hello, hello. Hello. Welcome to chat, friends. Tuco is getting a bit of rest on this chair here. I don't know if I'll talk much. This might be a quiet stream where I do terrible things to Grub. Trying to fix this camera that's missing. Want to bite those ears. Yes, I agree. Those ears are very soft. Oh yeah, OBS is misbehaving quite a lot right now suddenly. That's cool. It's, oh gosh. Oh, now it's looking entirely crashed. Oh, is it back? OBS might be back, but both the USB webcams are gone. That's useful. Oh, this one's gone too. Yeah, like, half my video input devices are dead now. Thanks, OBS. I mean, the problem might be something like USB electrical related, but OBS certainly doesn't recover from it gracefully. I guess I switch this back to the cat and then go unplug a bunch of wires from the back of the computer. Doesn't seem like that crashed OBS worse. Yeah, that's accurate. Comment in chat that OBS heard me say cursed and jumped right in to help. Yeah. Are all my USB devices still gone? Oh, right. Last time this has happened before. Last time this happened, I had to physically unplug the devices and remove and reinsert the XHCI module. I don't know if this is something weird about my motherboard or something weird about the USB Rube Goldberg machine in my studio. It's not what I was expecting to debug on this stream. Yeah, I don't know that I can blame OBS. I mean, OBS is bad at recovering from errors. Like the entire UI froze because of some something in the kernel just timed out. My LSUSB completed, and OBS from my end appeared to freeze for like 4 seconds. And LSUSB is only showing hubs. Is it showing all my hubs? This sucks. Do I need to reboot the hubs? You'd have to put an external... I vaguely remember having to put an external USB 3 PCI card in this machine at some point. I don't think I have enough PCI slots for that, though. This runs on like a garbage motherboard, and I think the only free PCI slots... yeah, I'd have to give up a video capture card if I wanted a better USB card, probably. It'd be cool to know what the root cause of the problem was. I suspect it's just some of the, I've got all these extensions that are moving the USB signal from this area to where the computer actually is. And I suspect that some of those are just causing errors that the driver is not recovering very well from. Just got a warning from YouTube that my video is bad. Thanks, YouTube. Well, maybe I've got to do this in the other order and RM mod the XHDI and then replug everything and then reinsert XHDI. Streaming everyday thing is going great. LS USB is still hanging. I guess I could probably add a way to show you this current computer on here since all the video grabbers are broken. Okay, which is a little freezy now. Yeah, LS USB finally came back, only with the hubs now. What is even going on here? The window manager is frozen now. Like here I was thinking I could actually show you what's going on, and I can't even move windows around the screen, much less actually interact with OBS at all. Oh, actually, is this just that unrelated KVM problem? Sometimes something that's going on either with my KVM or my mouse or my keyboard. That's it. Yeah, I think it gets the X server into a state where some modifiers are down or messed up, and I just can't interact with anything. That's just a different problem. Anyway. That sure is an aspect ratio difference. Oh, it's just very dark in that spot of the image. That's a good question. Other than nothing working, how's it going? It's going. Things have been better, but things have also been worse. I'm trying to make sure this guy eats more. He hasn't been eating enough. In terms of minor victories, I feel pretty happy with my audio setup. I mean, the mics and the filtering and all that are still not perfect, but it's a big improvement over what I had before. And there are parts of the setup that at least excite me. Like, I previously had this exact same sort of USB Rube Goldberg machine behind my audio also, which I'm sure wasn't helping. And so now the audio is running off of a Raspberry Pi Jack server, and I've got basically multicast UDP acting as a low latency audio network to keep a couple of studio computers in sync and connect them over a long wire to the audio interface. So that's working out a lot better than the previous thing. It means that I can run like a full-on DAW on either of the two computers that I have set up for this. And I can even route stuff in between the two if I want. And like right now I've got one of these computers running the stream and the other one is running like source material recordings. So it's got a multi-channel audio recording of unprocessed input, and it's got like high resolution, high bitrate recordings of the source videos. There's a question about whether I'm eating enough. Sometimes. I sometimes eat enough. I've been trying to actually buy food regularly, and not worry too much about food being expensive and not worry too much about like what to eat. Sometimes my housemate makes food to share, and that's pretty awesome. We cooked together last night, and that was pretty cool. Yeah, part of the audio problem before was the crackling. I think some of that was electromagnetic interference and some of it was buffer underruns. I don't know how much of that was actually USB dropping packets and how much of it was just scheduling dropouts due to just the Windows machine. The same computer, but when I had it running Windows before, it was just having a bad time in various ways. Like it was having trouble regulating the temperature of its GPU. It seemed like some kind of like driver issue there. I had to manually crank up the fan speed. It seemed to be experiencing some kind of like low-level reset every so often where the fans would change speed abruptly, like on a regular basis, like every couple seconds. The fans would suddenly change speed and then change back to what they were doing, like some low-level system component was resetting. I don't know if that was just like a normal level of badly designed system jank for an old Dell trash machine, but or whether something is specifically broken. But whatever the root cause, wiping the system and installing Arch on it seems to at least make it behave better. And then we have problems like this. So, I mean, I think the hardware is basically just cursed. Here I am trying to make a cursed bootloader for a voting machine when the machine I'm streaming from is cursed enough on its own. So, the thing that I did last time on the way to fixing this problem, or at least temporarily working around it, was to gradually re-plug in the USB devices. I mean, I was doing it then to try to isolate what the problem was, but that might have actually been necessary to get it running again, so maybe I'll just try to do that. There are three main USB cables going into the machine. There's a USB 3 video grabber, which is fairly important for this setup, and there are two cables that go off to long USB over twisted pair adapters, which eventually end up in here. And I can reassign those to various things. I think right now I've got one of them in use for a camera, plus the USB hub that has some other interface things. And then, yeah, I think I've got the other one. I think I've got a camera on each of them, and then some HID devices on each of them, basically. I unplugged everything and then plugged just the grabber into a different slot. Gosh, I'm so glad I have a way of getting input to this machine without USB right now, because that is also toast. That's promising. Can we add a thing? I'm gonna try to add a thing. We'll see if OBS crashes. Oh, is that it? That is still frozen with the old frame buffer. Can we reinitialize this device? Ooh, that's a new frame buffer. Checking the mode settings. All that looks fine. Ah. Okay. So that's fine. Let's plug one more of these in. Do we have now? Okay, that's still working. Ooh, that's not a good sign, unless USB is hanging. This grabber is still working though. And unplug everything from this side. Oh. There's a blinking light on one of these USB adapters that changed when I mashed on the connector slightly. That's an interesting sign. I think that was the cable going to one of the USB hubs over here. Yeah, maybe a USB hub with a loose cable is what's doing this, but gosh, that error recovery is trash if that's actually what's going on. The other device dropped off the bus too now. Yeah, how about that streaming my stream fumbling? I might just... I don't know how much more of this we should do. Duke, is that really comfortable? I don't know what that initial delay was about, but so now I've got the USB grabber and the other of those two cables plugged in. Don't know that we need the one that's unplugged right now. Gotta reset this thing again. Okay. It's the wrong camera. The grabber's not dead yet. I just plugged everything into different sockets this time. Yeah, I think there might have been some issue where I was running out of USB bandwidth and the driver wasn't telling me, but that should, like, USB should be, or Linux should be really good at reporting that. So I don't know what was actually going on, but I think swapping to different sockets on the motherboard and unplugging and replugging everything seems to have at least got the devices back. Yeah. That's the camera I was trying to get back. Thanks for bearing with me while we debug the studio. Oh. Okay, so the actual project here. I want to get this thing put back together. I'm tired of it taking up space on my desk. I want to be able to do things with it, but also do things with other hardware. So that actually kind of goes along pretty nicely with another requirement that I'm noticing I have, which is that if I rewrite the compact flash card too much, it will die. I'm already seeing bad sectors on this 64 meg compact flash card. So the flash card is small and it's unreliable and it's hard to get to. I really just need to put as little as possible on there and then have a different storage device that I do everything I can with. And I've been trying to sort of do that with the network now that I have this pcmcia network card that kind of works. But I just need to be able to get off of the compact flash card as early as possible. So one way to do that would be to have a very simple kernel with just a tiny bit of user space that lets me download an image of some sort from somewhere and then use kexec to boot into it. The advantage there is that I can use Linux's network stack and I can do network boot if I want to that way. That would be convenient in some ways. I don't actually know if I want that though. Network boot all the time seems like kind of slow. I don't want to get stuck having to network boot. I want to be able to network boot for debugging and development purposes. But it would also be nice if this thing could just boot off of a larger internal storage device. So if I modified this thing slightly by making some kind of mounting bracket and buying and or fabricating some cables and buying either another... There are a couple of steps, actually. I was going to say I would need to buy a couple of cables in order to add a larger storage device to this thing to boot off of. The BIOS doesn't seem to like larger storage devices, so one way to do this would be to still have a small internal device that the BIOS is happy with. This theoretically could be a tiny hard drive, but in practice it's going to be a compact flash card that's suitably small, whatever that ends up meaning, which seems right now to mean 64 megs or less. I don't know what the actual limit is or what the actual limit comes from at this point. But then there's room on this bus, theoretically, for a second hard drive that shares the same controller or shares the same cable. The controller is actually in the hard drive. That's Integrated Drive Electronics, or IDE, right? But it seems like with just a little bit of cabling, I could have a second device there, which could just be whatever size compact flash card or hard drive or whatever. So that seems like the technically easiest solution, is if I just attach a secondary device to that bus. That just involves buying and or fabricating some additional hardware. And I think there's a solution that's not too much more difficult that just uses the hardware I've already got in this thing. And I think we can kind of evacuate the compact flash card early on and just move everything to a pcmcia hard disk, which will be nice and fast. It'll be much faster than the network device. Even if we're having problems with the interrupts on the pcmcia controller, grub doesn't actually need interrupts for its disk driver. So if we get grub to talk to the pcmcia disk device, then it doesn't need mapped memory, which I think works, but we found some platform-specific quirks in already. And it doesn't need... it doesn't really need anything except like 8 I/O ports, I think. So we just have to place those I/O ports somewhere. grub, I looked at the code right now, it has, so by default, grub does not actually try to talk directly to the hard disk. By default, grub will use BIOS to talk to the disk, which in this case knows how to talk to the internal disk, and only if it's tiny, right? The BIOS is not super helpful. Actually, the BIOS we verified, I think, just passes through addresses without even bounds checking them. So I wouldn't be surprised if we could use the BIOS to like pass through LBA commands. I don't know if any of the modes would work, but it's easier, I think, at this point to just have grub talk directly to the storage device we want. So grub has a native parallel ATA disk driver. It's written for PCI, of course. There seems to be a sort of half-hearted attempt at a non-PCI, like legacy ISA compatible mode that's if-deft under some weird platform that it was like a QEMU MIPS platform or something weird like that. So, but the code looks fine. Like, I'm thinking maybe we patch grub first of all to enable that code path. So we're using the fixed IO port addresses instead of using PCI probing for that piece of hardware. And once we have that driver, I think then we also just need some code that actually sets up the pcmcia slot. So that would be specific to whatever the slot the card is actually in. It would turn on the slot, assign it an IO address, and that's just a couple of IO writes to the pcmcia controller. We could write C code to do that. We could also just put that in the grub config file. So I'm imagining a version of grub that is patched fairly lightly, just the necessary patches, which in this case would be this non-PCI patch for the disk, and also the thing we did earlier to remove PAE mode switching from the actual boot code in grub. So a lightly patched grub, a config file that handles most of the hardware weirdnesses on here, like the watchdog timer and turning on the pcmcia controller. Maybe we can even put the pcmcia controller in extended mode if we feel like it. We could even write something to the text LCD there. And then it could just transfer control to a second grub config file on the removable card. And now I've got an easy way to put removable programs onto this machine. So I think that's the plan. What were we even doing here? So we've already had to trim down the size of this card because we're finding bad spots. I should just pick a size. It seems like maybe 16 megs would be a good size to aim for, but I mean, if this is just grub, it could probably be pretty small. Like, could we get away with a 4 meg boot image? That would fit on any of these cards, but again, we might have to recompile it for different cards depending on the geometry of those cards. All right. So we did already have one patch in grub. We can add that. Okay, so I guess I'm clarifying that this is just the boot disk. Really, 64 sectors or cylinders. It's gotta be way more than that. Should we leave a little bit of room, maybe 60? See if that's enough. There's gotta be a better way to get these debug symbols out. Yeah, we never need this to have a journal if it's going to be read-only. The root fs can be basically empty except whatever stuff we want to put there, like presumably a grub config file. And then grub itself comes from this bootloader installer image, which we built above. Oh. Hey, boy. Oh, don't go there, but you're so cute. Hmm? I just need to update these variables. Oh, don't scratch at the screen. Sometimes, oh. I think Tuco looked at the screen right as I was scrolling something and it got his attention. Oh, Tuco, don't do that. Right? Hey. What? Oh, hey. Oh, hey. I guess all, I mean, that, oh. Hey, come on, Tuco. Tuco, are you hungry? Will you eat that? Oh, honey. Tuco, you're so demanding of attention, and I love you. Hey. You want this? Oh. Oh. Okay, Tuco, I get what you're saying. Oh. Tuco's on the control key. This could get dire. Honey. Control X. Oh, Tuco. No, see, we already have 2 patches in grub. We just need a second or a third. Oh, Tuco. Oh, no. Okay, let's use a different computer while Tuco's on this one. I'm using the kernel to do the bootloader install, but the kernel does not actually need to be on the grub image. He does look really handsome on the keyboard. It's a good cat perch. Let's move that out of the way. Got this ugly space mouse in the background. Yeah, I shouldn't worry about having just like a single target, really. The debug builder, the root disk, or the boot disk image builder, and the root image builder seem like kind of distinct things for the makefile to invoke. Oh, except exporting the image is actually kind of slow, and I didn't want to have to do that too many extra times. Fine. Oh, Tuco. We might need a cat purr microphone here. So I want to be able to run this on QEMU for testing, and QEMU, I don't think it implements pcmcia. I don't know if I'd want to use it, even if it does. I think the simplest way to get this working for testing is just to tell QEMU I have two IDE disks, and the second one will be at the I/O address of the second IDE disk, which is where I'm going to configure the pcmcia slot to map it. I don't know if that needs to be 1 or 2. Mm. Oh, not the bootloader installer, right? That's the wrong image. That's the boot disk builder. To go. I thought I knew that URL, but I clearly don't. Here it is. Oh yeah, I guess I have the BusyBox version of that, not the E2FS progs. Is grub. Cool. Hmm. Tuco, don't crawl back there, please. Okay, Tuk. Hey, honey. Tuk, don't be back there. You're just trying to my wires, aren't you? Oh, gosh. Did we just disconnect the chat laptop? Oh. Kitty. Well. Cat butt. Oh yeah, you scratched the fish. Okay, as long as he doesn't bite the wire. Need him to eat the meat and not bite the wire. But scratching the fish is always welcome. Tuka, are you going over there? Hey. Hey, Tuco, don't do bad things. This is no longer active. Click, click, click. Oh, that's right, I unplugged this keyboard. There we go. It works if I actually pick a partition. I guess I could stop having the boot subdirectory if this is now my boot partition instead of my root partition. Oh yeah, I didn't bother to actually set a partition for the second disk. It's fine. We can do that, however. Anyway, this is a much bigger system. With its own grub config. So like theoretically want to set up pcmcia and then transfer control to that config file. So I think right now, if we try to run this native disk command, I don't think it'll work. I think we're emulating a system without PCI, and I think grub, the way it's compiled right now, is going to expect PCI. Seems to not be working, but we also don't have any debug info. I can't even reboot. Tuco is a good cat. Okay, so that's what ls shows before native disk. Turn on some debugging. Run the native disk module. We basically can't see what happened. This experiment might work better if we were using the emulated serial console too. Okay, so we actually have scroll back now. So this is going to run through a whole bunch of different native disk modules. These are things where it's hoping to actually get direct access to something rather than actually having to ask the BIOS to do all the sector reads. So parallel ATA is the one we want. This version is trying to load PCI. I guess we're not getting very far with that because then we're right on to SCSI, AHCI, USB mass storage, OHCI. OHCI and UHCI are different flavors of USB host controller, and AHCI is a SATA host controller. EHCI is another USB host controller. So yeah, we need to modify grub. If we modify grub, this might actually run under QEMU, and so that'll be the next thing to test. Okay, I think I already had a grub source tree that was handy for making patches. Yeah, here we go. Grub machine MIPS QEMU MIPS. Within this driver, at least, that pound defined actually means don't use PCI. So we're switching initialization functions. Previously, this was scanning the PCI bus, looking for stuff. We're switching to this version that just hard codes 2 I/O addresses. And I think that's basically it. I'm going to put grub in the name of the patch there. See if that will blend. Yeah, drinking water is a good idea. See, it'll sound terrible, but then it'll remind everyone to stay hydrated. I don't want to count my chickens before they've overheated, but the camera's doing alright so far. It seems better when I have the SD card ejected. So I guess I just put the card in when I actually want to record some 4K video, but otherwise I can just get 1080p out the HDMI port. Okay. Oh, looks like we have ATA hard disk. It's taking its time to set up, and or it's failing and retrying. Oh, maybe that was just slow. Maybe it's just really slow. I wouldn't be surprised if this parallel ATI driver is in fact extremely slow. But it's probably way worse in QEMU. It also only needs to load the kernel. And I'm definitely trying to read. Yeah, we have an ATA 0 device, an ATA 2 device. I guess every time we do a top level LS, it's redoing the disk detection. What if we did ATA 0, comma, or /boot? Oh, sorry, ATA 0 had a partition. I meant ATA 2. This is gonna fail. It's failing slowly because it's trying to load a bunch of different file system modules. I love to fail slowly. That's really bootloaders and low-level storage is finding new ways to fail slowly. Anyway, next step here might be to move this to the real hardware and connect over the serial port and see if we can work out a set of steps that are necessary to initialize the pcmcia storage device. At this point, I don't know whether it's going to be slow in general or just slow in QEMU, but I'm not really sure it matters. Right here, it's just stuck doing something that it's going to take a while to fail doing, I guess. Trying all the file systems to open something that is not actually a file system because it's got a partition table. Yeah, maybe I should have fewer grub modules. 4 megs apparently is enough space to get into trouble. Okay, let's update the boot disk. I guess I should really start verifying the boot disk, huh? Hugo has been chewing on the serial cable. It's like not the worst thing for him to chew on, but it's not great for sure. It is a bit of Cat 5, so it's relatively expendable. And I imagine he can break it pretty extensively before I start to notice problems on RS-232. But I actually don't want him chewing on wires. For his health and for my equipment. Oh, that's so much faster. Thanks, 4 meg card. Ooh, some glare. We're going to want a completely different grub config for this. Wire down. Okay. Gosh. That's the flakiest connection. Okay. Ooh, OHCI. Well, that's not helpful. It might be worth actually going through and removing the grub modules that make no sense. Maybe I'll just remove the modules. Yeah, I mean, the right way to do this is actually to give grub some compile time options to just not even build these modules I don't want. Oh, I guess instead of running native disk, which is like an aggregate thing that tries a bunch of drivers, I could just insmod parallel ATA. That's a good sign. This parallel ATA driver is indeed very slow. It's not just in QEMU. But it does seem to work on the compact flash card. I didn't anticipate that this driver would be so slow. It might be interesting to figure out why. It might just have some really conservative timings. Oh, I don't know why I have Tuco's food in front of me and not in front of Tuco. Okay, so this tells us that we can just boot grub normally, get to the command line, manually install parallel ATA, and I have to be careful to load the other modules I want first, because once I do that, I'm in a state where I can't load grub modules until I set a new prefix or a new root directory for grub. So that's all stuff that I'll need to do carefully in the grub setup script. But right now, at least, a good test setup would be to see if I can configure pcmcia manually with the IO port commands, and then do the same experiment and see if I also see ATA2. Just confirming the address we want, but yeah, it's OX170. Okay, let's get a fresh boot. All right. So we'll need a bunch of register documentation to do this. I'm going to mostly just want this document. Register set. So the first thing to check is to see if the PC card controller itself is enabled in the system specific registers. I think it is. I think the BIOS left it on, because otherwise we would have had to set this up for Linux also. I thought those were in the section before all the PC card registers. Yeah. This is it. Maybe I'm misremembering this. Let's check the other document. The manual had a, like, that's more like a description of how to turn on the controller, whereas the register list is just a reference. So yeah, here we go. Initialization. CSC D0. Okay, D0. Internal I/O device configuration register. Okay, D0. Yes, PC card enable bit is already set. So the BIOS left the PC card controller turned on for us. That is this bit right here. Okay, I think everything else we want is in the PC card controller's registers. It'd be cool if I remembered 100% for sure which PC card slot we were trying to turn on. I think it's slot 0. I could be wrong about that though. We could boot back into Linux and check it out in there. We could also try to read the card's information manually. I was just gonna sort of turn it on and set the I/O address. Oh, let's make sure we have some space clear in the I/O. 170, right? Let's make sure it looks like nothing's actually at 170. Looks okay. looks like an empty bus. Cool. So right now, writes seem to have no effect. Reads are just giving us OXD, which seems pretty arbitrary. Let's try to map something there. So first we need to turn on the card. Well, let's try to read the card detect while we're here. I don't know if I'll actually have my script do this. I think I'll just have it assume the card's there, because what else? What are we going to do in the event of... I mean, I guess grub... Does grub support conditionals? I'll have to check. I was just going to assume we just have a linear sequence of commands, though. Is that right? Does that make sense? C. I think so. I think that means there's a card in both sockets. So then I think what I want is auto power control and VPP disabled and IO mode. Guess we just set these two bits. Bits 4 and 5 on register 2. Oh. Power active and ready. Okay. So far, so good. So now let's set this register, the interrupt and general control register. This is 03. What is it currently set to? Set to 0. So IRQs are disabled. The card is being held and reset, I think. So let's leave IRQs off, but let's put it in IO mode and maybe take it out of reset. That's 60 to register 3. Okay. And now let's try to map the IO space. Okay, we want to turn on this IO window enable, but not until we set it up. IO window control, we want to set the window to be 16 bits wide. Default is 8 bits, which is not what we want. Maybe we just want to change that from 0 to 1. Okay, 16-bit IO window. Start address, we wanted this at 17. Okay, we set up the window, but it's not enabled yet. I think we need to enable it, and then maybe stuff will change. Okay, that should have been the command to enable the I/O window. Ooh, different behavior. Now it crashes. I should unplug it in case there's bus contention. Now we're getting somewhere. Oh, cool. Let's work on a new grub config for this. It's a good sign that it crashed when I wrote to that address. Like, it seems like the mapping is correct. I maybe just am missing any number of other things, really. This is not even worry about the menu. Except for... I never set the offset registers, did I? Does that even matter for I/O space? This is the weirdest grub config I've written in a while. I don't know what this timing set bit should be set to. Maybe I'll set this to auto window size instead of 16-bit wide. I thought IDE disks were always 16-bit wide, it's just a lot of the registers only use 8 bits. Well, I'm going to change one thing at a time, and I don't think I'm going to change this. Let's keep this set the way it was. I should look up exactly what these stop addresses are. Also, I've been assuming they're the last address in the region. They might be the address after the last one. Probably doesn't matter yet. Oh, is there no I/O window offset? It might have crashed because I might have written to an IDE port without any disk selected. I want to check the Linux source code for this to see if there's any hidden gotchas in setting up these I/O mappings. Timing register. slightly concerned about the timing registers. Not as much as if we were actually talking to an old device, though. The thing that's in the slot here is a modern ATA to SD adapter chip. It's right there too. I don't still have any logs that would include Linux debug information from that driver. That might be the thing to do, is to run this in Linux and see exactly how it's setting up the card and just take the same register values. We do, in fact, have some Linux debug info. Oh, yeah. This is the card we're interested in. So they're mapping a memory region here, but I don't think we actually need that memory. Okay, they were using auto size mode. I guess we can use that. And it looks like whatever the fastest speed is. We could also check on this set socket over here. There's not much this driver is doing. Oh, what is output enable? We had IO card. That sounds necessary. That's interesting. Are we not using auto power on? It seemed like a good idea, but we could totally not use it, I guess. And that other stuff has interrupt configuration. Is that the bit that it's calling 5 volts? Are we really talking about the same register? Right, power and reset driver control. Yeah, I don't know what this is here. This. Like, that's just the VCC enable bit again, but we're talking about it as a 5-volt VCC bit. Whatever, I think I know what value to set this to, it's just the documentation doesn't always make sense. Okay, register to VCCN PPP 0. Still hanging on the first IO cycle. Maybe it'd be useful to have that logic analyzer back on the ISA bus. We could try mapping these to a different location. It's possible possible something else is going on with that stuff at OX17 and like I don't know, it seemed to be open, but like maybe we're having a bus conflict. Could try setting it to OX400 to match what Linux was doing. Now it's just acting like nothing's mapped. Did I do that wrong? Yes. Okay, so I can crash even if I map it elsewhere. So I'm guessing that this is something either with the timing or power configuration on the pcmcia socket. I feel like we're getting close though. Like this is basically got all the pieces we need. Just needs a little bit of debugging, and then we should be able to get grub to boot off of the removable larger card. Yeah, it looks like the stop addresses work how you'd expect them to. Right, so this is the start address, that's the stop address. Well, maybe that's a decent place to wrap this up. We've got basically a prototype of something that should interact with the card. It's not working, but it seems like the kind of problem where if we attach a logic analyzer or possibly even look at maybe even analog would help, right? Because like this seems like the kind of problem where it would be useful to know who's even driving the bus during this bus cycle. So could probably modify this very slightly to give a good scope triggering point, or just trigger off of any of these IOs, really. Well, let's enjoy Tuco for a minute, and then I will leave you to the rest of your evening. This has been a bit of an adventure just getting Linux to boot on this thing. So far, Grub has a few patches. I've got the most important patch was actually to remove some PAE mode switching code in the low-level bits of Grub that was preparing the CPU to boot up the new operating system. That was just flat out faulting on the 486. Yeah, and then another little BIOS bug workaround so that I could boot off of disks that are a different size than the BIOS thinks we have. And now, no PCI mode, and getting us ready to talk to this pcmcia disk. Tuco's such a good guy. Oh, I just noticed the question in chat about what that OX3EO IO port was. Yeah, that's for the pcmcia controller. It is kind of compatible with the Intel i82365 controller, but it has a bunch of differences, and so the canonical definition of those registers really is in the documentation for the system on chip. So I've been referring to that. The system on chip is an AMD SC400, which has an AM486 core and a bunch of on-chip peripherals. Well, have a good night, folks. we will revisit this tomorrow with a logic analyzer attached, I think. See you then.